In 1974, humanity sent a powerful message into deep space, a cosmic shout saying, "We are here." For almost 50 years, we only heard silence. But then, something strange happened. A mysterious object called 3I/ATLAS appeared out of nowhere, traveling on a path that didn't make sense. Its speed, its route, even its shape, everything was different from anything we'd ever seen. This forced scientists to ask a frightening question. Did someone out there finally answer our message? Have you ever wondered what it would be like if a visitor from another world came close to us? In the early days of the year 2025, astronomers all around the Earth saw something new moving across the sky. It was not a star, and it was not a planet. It was not one of the usual comets or asteroids that they were used to watching every night. This strange moving dot caught their eyes because it was on an unusual path, and it was going very fast. The people who found it decided to call it 3I/ATLAS. The name 3I/ATLAS was not chosen by chance. The 3 in the name means that this is the third object of its kind that people have seen. The I stands for interstellar, which means it does not come from our solar system. It comes from far, far away. The ATLAS part is the name of the project and group of scientists who first noticed it. These scientists use big and powerful telescopes to look at the sky every night. Some of these telescopes are very tall and are placed on mountains, while others are kept in special domes or even out in space, far from the noise and lights of our cities. Not long after they reported it, other teams of scientists all over the world pointed their own telescopes at 3I/ATLAS. Excitement spread because it quickly became clear that this was not a common object. Most of the time, when a new spot is seen in the sky, it turns out to be just another comet moving around the sun in a path that has been seen before. But 3I/ATLAS was different from its first appearance. It was moving much faster than comets or asteroids usually do. Its path across the sky did not make an oval or a circle. Instead, its path was wide, sharp, and quick, like a straight line flying through our solar system without stopping. When scientists see something unusual in the sky, there is a set way that they try to understand what it is. First, they try to follow its journey. They work out where it came from, how it is moving, and where it will go next. With 3I/ATLAS, this was not easy at first. Its speed was so high that it looked as if it was not being held by the sun's gravity. Most comets go around the sun again and again, but this object looked like it was passing through only once. This was the first clue that 3I/ATLAS might have come from outside our solar system. When scientists realized this, they became even more interested. Things that come from other solar systems or from places beyond the sun are very rare. Most comets and asteroids that pass near the Earth were born at the same time as our sun, many billions of years ago. They still travel around the sun, trapped by its gravity, making regular visits as they go along their orbits. To see an object from somewhere else in the galaxy is very special. In all of history, only 2 other interstellar objects had ever been found before this one. The first was named Oumuamua, and it was seen in the year 2017. The second was called 2I/Borisov, found in the year 2019. Because of this, astronomers dropped everything to focus on 3I/ATLAS. They watched its every move as it crossed the sky. With every hour that passed, they wrote down its position and took new photos. They worked together, sharing information quickly so that even people in countries far apart from each other could help. The object was moving so quickly that they knew it would not be visible for long, and if they waited too long, they might miss it forever. To make sure they could learn as much as possible, scientists used all the tools they had. Some telescopes could see colors and brightness. These told them how much light the object reflected from the sun. Others could break up the light into many parts, like how a prism shows different colors. Each color can show what something is made of. By watching how the light from 3I/ATLAS changed as it moved, they could try to guess what kinds of things were on it, like ice, rock, or dust. While scientists worked, news about the discovery spread to many people. Some asked if the object could be dangerous. When something is moving so quickly and seems new, people sometimes worry that it might crash into Earth. This has happened before, with large asteroids millions of years ago, so it is a fair question. Right away, teams of scientists did careful checks using computers and math. They looked at the path of 3I/ATLAS to see if it would come close to the Earth or to any other planet. After several days of watching, the scientists were able to say clearly that there was no danger. 3I/ATLAS was not on a path that would take it close to any of the planets. It would swing in toward the sun, then turn away quickly and leave our solar system forever. It would become just a memory and a number in the books of astronomers. With these words, people relaxed, and their worry turned into curiosity and wonder. What could we learn from such a rare and fast visitor from beyond the sun? As days passed, even more details began to appear about what kind of object 3I/ATLAS really was. Using the largest telescopes, astronomers could see that it was an icy body. This means that most of it was made up of ice, covered with rock and dust. Some of this ice could be water ice, like the kind we put in drinks, but it could also be made from other gases that freeze when they are very cold, like carbon dioxide or methane. Sometimes, when the sun's heat touches an object like this, the ice can turn into gas and come off the surface, making a thin cloud or a tail. This is what happens with many comets, and it could happen with 3I/ATLAS too. Still, measuring the size of 3I/ATLAS was not easy, because it was far away and so quick the object looked very small. Even through strong telescopes, scientists made their best guesses by looking at how bright it was and how sunlight reflected from its surface. They also watched for any changes as it moved, like if it got brighter or developed a tail. Each little detail, such as shape and color, gave another clue about what it was made of and how it was different from things we already knew from our own solar system. Other scientists used computers to try to track where 3I/ATLAS came from. They plotted its route backwards in time to see what part of the galaxy it might have traveled from. The computer models showed that it was not possible to say for sure where it started. It had probably floated between stars for millions of years before reaching us. Space is very big and mostly empty, so traveling even a short distance between stars can take a very, very long time. While all this careful scientific work was happening, some people started asking even bigger questions. In the year 1974, something very special happened. Humans sent out a strong radio message into space from a place called the Arecibo Observatory. That message was meant as a greeting to anyone who might be out in the galaxy, living on a planet around another star. Scientists included information about human beings, the Earth, and even how to understand the message in case it was ever heard by other intelligent creatures. Nearly 50 years later, 3I/ATLAS was seen flying into our solar system. Some people, just for fun, wondered if there could be any connection. They asked, what if this object was not just a piece of rock and ice? What if it was some kind of answer to our message, or was even an object sent by creatures from another world to visit us? Stories about this idea went around, and it made the discovery even more interesting for people everywhere. Sometimes when things from space are so rare and strange, it is natural for people to dream up wild possibilities. But most scientists did not agree with this idea. They spent many hours looking at the details of 3I/ATLAS and learned as much as they could. If it were a machine, it might move in straight lines, or have lights, or send out strong signals. None of these things were seen. The way that sunlight bounced from it and the way its path curved around the sun were just what would happen for a natural object. Its surface, color, and all the changes it showed looked a lot like comets and icy rocks already known to exist. No patterns, signals, or odd movements suggested anything different. Instead, 3I/ATLAS looked like something born in another star system, shaped by natural events, and then pushed out into space by the gravity of the stars a very long time ago. Even if there was no sign of life or a message, the arrival of 3I/ATLAS stayed important. Each time an interstellar object is found, it is like a messenger from a place too far away to visit. Scientists could study the light from the object, breaking it into its colors to search for fingerprints of chemicals and elements. This lets them discover things about far-off worlds that they might never see with their own eyes. It could even help us understand how planets might form around other stars and what kind of materials might be out there waiting to be discovered. The discovery of 3I/ATLAS was also good for another reason. It was a chance to test all the science tools that help find small, faint, and fast objects in the sky. Because it moved so quickly, everyone had to work fast and share their results. This meant that scientists in many different places could help each other, improving the way they look at the universe together. Each time an object like this is found, the tools and methods get even better, which means more interstellar visitors may be found in the future. So, what does it mean when something like 3I/ATLAS passes by our solar system? It reminds us that we are not alone in the universe. It is a sign that parts of other star systems can come close to us, even if only for a short time. These visitors show us that space is full of surprises, and there will always be something new to look for, to study, and to learn. With each new object from beyond the sun, there is a chance to discover more about our own place in the universe and to reach out a little farther into the unknown. And so, the story of 3I/ATLAS began with the eyes of a few astronomers looking up at the sky. But it quickly became something that connected scientists and curious people everywhere. It showed us that sometimes even a small speck moving across the night sky can hold big mysteries, and that every discovery leads to new questions and fresh wonder for everyone on Earth. Sometimes, when people see something new in the sky, there are many questions that follow. 3I/ATLAS brought not only excitement, but also a chance to talk about things that are not often explained, like what it means when we say interstellar object. This was an unusual name for most people. They wanted to know how 3I/ATLAS was different from the many comets, rocks, and icy bodies that have been known for many years. Understanding this difference helps us see why the discovery of 3I/ATLAS was so important and rare. Most comets and asteroids that people have discovered were formed along with our Sun a very long time ago. Our solar system is made up of the Sun at the center, the planets that travel around it, and many smaller objects like comets, asteroids, and dust. Nearly all of these objects were created from the same swirling cloud of dust and gas as the Sun over 4.5 billion years ago. These objects have always been part of the Sun's family, traveling around it in steady, repeating paths. Astronomers call the Sun and everything that is pulled by its gravity the solar system. Gravity is the invisible force that keeps Earth and the other planets from drifting away into space. This force ties together not just the large planets, but also many billions of tiny pieces of rock and ice. Some of these pieces can be as small as a pebble and others as large as mountains. Over time, small changes in these paths can make some objects travel closer to Earth or the other planets. Still, they are all part of the solar system and have never left it. But sometimes something arrives that is not from the Sun's family. The word interstellar means between the stars. An interstellar object is something that comes from outside the space that belongs to our Sun. Instead of being born with the planets, it started far away, close to another star somewhere in the galaxy. These objects have a very different story from the comets and asteroids that we usually see. Interstellar objects do not follow the usual paths that loop around the Sun. Most of them travel on open, straight lines that cross through the solar system quickly. Their speed is much higher than anything that comes from our own neighborhood in space. If you follow their tracks using math and a computer, it becomes clear that they cannot be caught by the Sun's gravity. Instead, they fly in from far away, pass near the Sun, and keep going out into the stars. So far, people have only found 3 interstellar objects. The first, Oumuamua, was found in the year 2017. The second, 2I/Borisov, appeared in the year 2019. And now there is 3 I/ATLAS. Each one taught scientists something new. For a long time, people wondered if it would ever be possible to see an object from another star, because the space between stars is so big and so empty. Before the discovery of the first interstellar object, astronomers looked for comets and asteroids only to learn about our own solar system. They studied their shapes, their orbits, and their materials. Every now and then, comets would come from the outer parts of the solar system, from a place called the Oort cloud or the Kuiper belt. These places are very far away, but still belong to the Sun. The comets that come from there can take thousands or even millions of years to make one trip around the Sun. But they always return over and over because they are held by the Sun's gravity. Interstellar objects like 3I/ATLAS are not the same as these faraway comets. Their paths do not curve back to the Sun. When astronomers follow the tracks of an interstellar object, they see that it comes into the solar system, swings around the Sun, and continues outward, never to return again. This shows that it must have started far from the Sun, outside the reach of its gravity. These visitors come from the space that lies between all the stars in the galaxy. The reason it is so special to find an interstellar object is not just because it is rare. These objects carry clues from other places that humans might never be able to reach. Our solar system is only one among many in the Milky Way galaxy. There are billions of other stars, each with its own family of planets and smaller bodies. Sometimes, when planets grow or when stars pass closely by each other, pieces of rock, ice, or dust can be thrown out. These pieces then float in the dark for millions or even billions of years, crossing huge distances. When one of these pieces finally comes close enough for us to see, it brings information about how other star systems are formed and about the kind of matter that exists in faraway places. With each new interstellar object, scientists hope to find something new about the history of our galaxy. When Oumuamua was discovered, it looked very different from any comet or asteroid we had seen before. Its shape was longer and thinner than any other space rock. It spun and reflected light in a strange way. It did not show a big, bright tail like a comet, making it hard to understand. Years later, with 2I/Borisov, scientists saw something that acted much more like a comet, with a cloud around it and a clear trail of gas and dust as it passed by the Sun. These two discoveries showed that interstellar objects can be very different from one another. This makes every new discovery even more important. Scientists have only a short time to study each visitor because they move so quickly and soon become too far and too faint to be seen. Every time a new interstellar object is found, telescopes from around the world rush to observe it before it is gone. The way scientists tell whether an object is interstellar comes from careful watching and measuring. First, they track its motion across the sky. If the object's path is fast and wide, not closing back on itself, this is the first clue. It shows the object is not returning, but only visits once. Then they measure its speed. If the speed is high enough to escape the gravity of the Sun, it means the object cannot be part of the Sun's normal family. In other words, it has come from beyond. Another important way to check if an object is interstellar is to study its materials. If a comet or asteroid looks the same as those made in our solar system, scientists still try to look deeper. They check what kinds of ices or rocks are present. Sometimes they see chemicals or patterns that are not common in other comets. Every small difference is a clue. To understand more, scientists use machines called spectrographs. These machines break the light that comes from the object into a rainbow of many colors. By looking at which colors are stronger or weaker, they can find out which elements and molecules are present on or in the object. Sometimes an interstellar object will have a fingerprint of chemicals that we do not see often in comets from our own solar system. Not only do scientists study the materials, but they also try to work out how old the object is, how long it has been traveling, and what might have pushed it out of its distant home. This is not easy. The space between stars is enormous and mostly empty, so objects can float for millions or billions of years without changing much. By watching details like how fast it spins, how its brightness changes, and if it has a tail or not, astronomers learn if it has been through hot or cold places and what kind of history it might have had. Another clue to the story of an interstellar object is how it enters the solar system. Scientists can roll back its journey using computers and see which direction it came from. Sometimes they try to see if it might have passed close to any known stars before. This gives hints about where its home star might have been. Astronomers are always hoping that by finding more interstellar objects, they can build up a bigger picture of the galaxy's history. Most of what we know about other stars comes from looking at them from a distance. But when a piece of another star's neighborhood comes to us, we have a small sample to study more closely. This gives us a much stronger way to test ideas about star and planet formation. The search for interstellar objects is not new, but it has only become possible in the past several years. The main reason is technology. Telescopes have become much bigger and better. Cameras, software, and computers have improved. It is now possible to scan the sky every night and look for fast-moving or unusual objects that were missed in the past. Programs like ATLAS, which helped find 3I/ATLAS, are made to watch for new visitors every night. Even with better tools, finding interstellar objects is still not easy. The sky is very large and many things can hide in its darkness. Most small objects do not reflect much light, so they look dim and can be missed. Also, interstellar objects move so quickly that they are often missed if they are not in just the right spot at the right time. The chance to see one is still very rare, which is why every new one is important to science. Now, with 3I/ATLAS as the third interstellar object known, astronomers are becoming more hopeful that more will be discovered. Each new piece, even a small one, helps fill in the story of how our galaxy formed and how matter travels from one place to another. These discoveries show that the space between stars is not always empty. Sometimes it is carrying pieces of distant worlds, moving silently through the darkness. Scientists are very careful when they announce an interstellar object. They want to be sure. They share their findings with other teams all around the world to double-check each part. They check the speed, the path, and every detail they can gather. Once everyone agrees, the object is officially named using a system that keeps track of all such visitors. The number in the name always shows the order in which interstellar objects have been found. Studying interstellar objects not only helps us learn new science, but also helps bring people together. Teams from different countries work at the same time. They share pictures, answers, ideas, and tools with each other. It is a true mix of knowledge from everywhere on Earth, united by the mystery and excitement of discovering something from beyond our world. From now on, whenever scientists talk about an interstellar object, they mean something that was born around another star in a place far outside the solar system. That object drifted for millions or billions of years, carrying inside it the history of a different part of the galaxy. When it comes close to the Sun, even for a short time, it gives us a rare chance to learn not only about its own past, but also about the story of the stars themselves. This is why the discovery of 3I/ATLAS means so much. For the first time in human history, people are beginning to see not just what is close to them, but also to reach out and learn from what comes from deep space, far beyond the Sun and its planets. The story of interstellar objects is also the story of how humans grow their curiosity, always looking up, asking questions, and working together to find answers. As long as new objects arrive from the distant regions of the galaxy, the universe will always have more secrets waiting to be discovered. When astronomers learn that an object is truly interstellar, their next goal is to understand exactly what it is made of and how it behaves. This is why so much attention was given to the object now known as 3I/ATLAS. Right after its discovery, telescopes all around the world were pointed at it. Scientists wanted to learn every detail they could about the shape, the color, the brightness, and anything else that could be measured. These details help piece together the story of where the object came from and what has happened to it on its long journey. People call 3I/ATLAS an icy body. This means that it is made mostly from ice and rock. Comets from our own solar system are built in the same way, but 3I/ATLAS comes from a place much farther away. The ice in an object like this is not only frozen water. In space, there are other gases such as carbon dioxide, methane, and ammonia that freeze into ice when they become very cold. All these ices, mixed with rock and dust, make up the main parts of 3I/ATLAS. Seeing what 3I/ATLAS is made from is not always easy. The object is very far from Earth, and it moves very quickly. Even with the largest telescopes, it looks small and faint. But astronomers have special ways to gather information. They use tools that can separate the light from 3I/ATLAS into its colors. This is called a spectrum. Each color in the spectrum shows a small part of what is there. For example, if sunlight bounces off frozen water, it makes a special pattern in the rainbow of colors. The same is true for other ices and rocks. Scientists looked at the spectrum of light from 3I/ATLAS many times. They searched carefully for the signs of water ice and the other materials. Some clues were easy to find, and some were hidden in dim colors. When they saw evidence of ice and rock together, it was another sign that this object was very much like the comets that come from our own solar system, but its path and speed told them it had come from elsewhere. Astronomers also wanted to know how big 3I/ATLAS was. In the emptiness of space, size is hard to measure unless the object passes right in front of something bright, like a star or the sun. For 3I/ATLAS, Scientists used brightness as a first clue. The more sunlight it reflects, the larger it might be, but this also depends on how shiny its surface is. An icy object can look bright or dim, depending on whether its surface is smooth, scratched, dusty, or covered with very dark material. Each night, teams watch to see if the brightness of 3I/ATLAS changed. Some changes might show that a thin cloud of gas called a coma was forming around it. This happens when heat from the sun makes the ices start to turn into gas. Sometimes a tail can even form if the gas and dust is pushed away from the sun by its light. By measuring how the size of this cloud or the brightness changed, astronomers could also make better guesses about the amount of ice on 3I/ATLAS and how it responded to the sun. Photographs taken during many hours showed that the color of 3I/ATLAS was neither very bright nor very dark. It was somewhat grayish or slightly reddish, which scientists expected for an object that had spent millions or billions of years in the cold and darkness of space. The outer surface looked weathered, meaning it had likely been hit by tiny particles and touched by weak rays from distant stars for a long time. These things change the outside layer of ice and rock, sometimes making it dull. More advanced telescopes in space, not blocked by Earth's air, collected finer details. They looked for special patterns in how light bounced from the surface at different angles. A surface covered mostly with smooth ice gives a different result than a surface covered with dust or small rocks. Step by step, scientists collected these details and built a clearer picture of 3I/ATLAS. As data grew, astronomers began to see how 3I/ATLAS acted. Its spin, or how quickly it turned around, was measured by watching how the brightness changed over time. If one side is brighter, the object will look like it flashes or dims as it spins. Scientists saw that 3I/ATLAS did not spin very quickly, and its brightness changed only a little. This suggested it might be somewhat round and not shaped like a long rod or a very flat piece. These facts were different from what was seen with the first known interstellar object, called Oumuamua, which seemed long and thin. They also watched for outbursts, which can happen when part of a frozen object cracks and suddenly releases a jet of gas and dust. These jets can push the object and even make its path change a small amount. In the case of 3I/ATLAS, no big outbursts were seen, but it did have signs of a gentle, thin coma forming as it came closer to the sun. This behavior matched what many comets show, but the unique speed and travel path set it apart as special and made scientists watch even more closely. Scientists also wanted to know if 3I/ATLAS was all one piece, or if it had broken apart. Space is full of dangers, including bumps from tiny rocks or the pressure from the sun's heat. If a comet or icy body stays in deep space a long time, it is possible it can get cracks or even break in two or more pieces. Observations of 3I/ATLAS showed that it remained as a single piece while it passed through the solar system. There were no signs of large pieces breaking away, and it kept traveling steadily on its path. While studying physical features, astronomers also paid attention to the gases that came off 3I/ATLAS. When the sun's heat warms the ice, different gases are released. These can be picked up by special cameras in telescopes. By checking for gases like water vapor, carbon dioxide, and others, researchers could understand even more about what types of ice the object carried inside it. These gases can make a halo or tail behind the object as it races along. Colors in the coma can also give hints about minerals or even very simple chemicals, such as fragments of carbon or traces of organic material. Sometimes organic material is a sign that the object went through special conditions in its home star system. But these materials are not the same as life. They are just chemical building blocks that are common in space. Scientists also thought about how long 3I/ATLAS had been exposed to space. Over millions of years, icy bodies like this can be changed by rays from stars, by cosmic rays, and by tiny pieces of dust hitting them again and again. Over a long time, the top layer can become dried or cracked, and the inside remains cold and fresh. When the object comes toward the sun, the inside ice can start to warm, sending new gases and dust out into space. Astronomers used many nights of data to find out if 3I/ATLAS was made by the same forces as comets from our solar system, or if there was something different about how it was formed. They compared its behavior to comets that have come from places like the Oort cloud and the Kuiper belt in the outer solar system. Some details were similar, but some things, such as the special mix of ices, the faint reddish color, or the way it only visited once at high speed, showed it really was from a different place. Mathematical models were also used to understand if 3I/ATLAS could survive getting close to the sun. In space, sometimes an icy body gets too warm and breaks apart. But 3I/ATLAS stayed whole. Its path took it much closer to the sun than some comets ever go, and still it did not split. This taught the scientists that it was made from strong material, or that its layers of ice and rock were tightly packed. While observing the object, teams worldwide checked carefully for any signals that might hint it was not natural. They studied to see if there were any regular patterns in the light, any flashes, any signs of metal, or anything that looked artificial. The shape, color, and how gas was coming off of it all pointed to a natural object. The evidence built up night after night, showing that 3I/ATLAS was just a rare icy body, not a machine or something built by intelligence. Scientists were careful to compare all this new data with the two interstellar objects known before. They looked at different shapes, colors, gas clouds, and speeds. Every fact, even something small, helped to fill in big gaps in what people know about objects that travel between stars. Each difference was recorded, and each similarity made scientists more sure that some rules of nature, like the way dust and ice mix in space, are the same across many parts of the galaxy. Questions were also asked about how much dust 3I/ATLAS was carrying. As it neared the sun, some dust was released. By measuring the brightness and patterns in the cloud, scientists could guess the size of the dust grains and how many were there. The kind of dust matters because it tells about the place where the object was formed. Fine dust says the object stayed in a calm part of its home star system. Big grains of dust show that maybe it came from a place with more action, such as close to other stars or near large planets. All these clues showed the scientists that 3I/ATLAS had traveled far and come from a very different place than Earth. It carried with it a story that was millions or even billions of years old. With every spin, every flash of brightness, and every bit of gas or dust that floated away, more was learned about the nature of the object. This learning was not only for astronomers. Information was shared with teachers, students, and sky watchers everywhere. Pictures were shown on websites and on television. People could see the journey of a real object from another star system as it passed by, even if it was only a tiny dot in the sky. As 3I/ATLAS continued on its way through the inner solar system, more measurements were made. As the sun warmed the object, it sometimes changed in unexpected ways. Some nights it looked brighter, other nights it faded. These changes showed that nature is full of mystery, and even after studying comets and icy bodies for hundreds of years, each new visitor still has something new to teach. The teams also thought about how much time was left to keep looking at 3I/ATLAS. Its speed meant that soon it would become hard to see. Astronomers worked together to take the best and most detailed images and data possible. What they learned would help in finding and studying any new interstellar objects that might come in the future. In the end, scientists began to understand that 3I/ATLAS, with its mix of ice and rock, its gentle coma, and its calm travel through the solar system, was more than just a visitor. It was a valuable key to understanding how other systems in space create and send out objects. By sharing their findings, scientists made it possible for everyone on the planet to look up at the sky and know just a little more about the wider universe. Each night's new information added to what was already known, helping to shape a new view of what is possible in the sky above Earth. The study of 3I/ATLAS showed that, with careful watching, teamwork, and a passion for discovery, people could learn secrets carried across great distances by something as simple and natural as an icy body from beyond the sun. As soon as scientists understood how special 3I/ATLAS was, they paid more attention to how it was moving through the solar system. The way something travels through space can reveal important secrets about where it came from, how old it might be, and if it has ever been close to other planets, stars, or big clouds of dust in the galaxy. Movement is one of the most careful parts of space study because an object cannot hide the marks of its path. Computers, math, and sharp eyes all work together to try and follow every part of 3I/ATLAS's journey. When astronomers first found 3I/ATLAS, they wrote down where they saw it each night. They continued to track its position hour by hour and day by day. Each time they made a new note, the growing list of points showed the object's path across the sky. They noticed right away that the journey did not look like the path of normal comets. Instead of making long, round loops or gentle bends, 3I/ATLAS was on a sharp, fast route. The shape of this path is important. In science, it is called a hyperbolic orbit. A hyperbolic orbit is different from the orbits of objects born in our solar system. Most planets, comets, and asteroids move in paths that wrap around the sun, pulled by gravity. These paths are shaped like circles or stretched ovals, but a hyperbolic orbit is open. The object comes in from one side, flies close to the sun, and then continues to go out, never turning around or coming back. This kind of path shows that 3I/ATLAS did not begin with the sun and will never return after its journey. Astronomers used many computer programs to figure out the best way to describe the movement of 3I/ATLAS. Every new observation helped make the path more exact. They used math to measure something called the eccentricity of the orbit. If this number is bigger than 1, it means the path is a hyperbola, which is an open curve, not a closed loop. The measured eccentricity for 3I/ATLAS was far above 1, leaving no doubt that it was just passing through and was not captured by the sun's pull. Besides the shape of the orbit, the speed of 3I/ATLAS was a surprise. It was traveling much faster than most comets or asteroids that belong to the solar system. Its speed told scientists that the sun's gravity would not be strong enough to keep it around. Even after passing near the sun, it would keep moving outward, never to come back. This speed is another big hint that it started its long journey outside the reach of the sun. Every night, telescopes followed 3I/ATLAS's movement very closely. Even small changes in direction or speed could tell a big story. Sometimes, when a comet lets out a lot of gas or dust, it can act like a small push and change how the object moves. Scientists watched for these kinds of changes but saw that 3I/ATLAS kept a steady course, suggesting that it was whole and that the gases escaping were not powerful enough to send it off its path. The closest point in 3I/ATLAS's path to the Sun is called perihelion. Astronomers work hard to figure out the exact date and distance for perihelion because it helps them plan their best observations. For 3I/ATLAS, this point was not very close to the Sun, but it was close enough for scientists to see the object change under its warmth. They recorded when and where this happened, marking an important step in its journey. After perihelion, they confirmed by watching that 3I/ATLAS would soon cross paths with the outer edges of the solar system and begin moving into the dark space between the stars. The movement of 3I/ATLAS was not only interesting for its own story. Scientists also wanted to know how likely it is that more objects like it might pass by in the future. By mapping its path, they looked back in time, using powerful computers to guess where it could have come from. They saw that before entering the solar system, 3I/ATLAS moved along the galaxy's own direction, almost as if it was following the same route as the Sun and other stars. This is one more sign that its trip through our sky was a result of chance, after a huge amount of time drifting through empty space. Astronomers also wondered if the path of 3I/ATLAS could be traced all the way back to a certain star or region in space. This is hard to do because as the object travels, even very small bumps or pulls by nearby stars, planets, or clouds can change where it ends up. Over millions or billions of years, such tiny changes add up. So, although they could see what direction it entered from, it was not possible to find a single original home for the object. It likely began very far away and traveled for longer than people can imagine. While they looked at where 3I/ATLAS came from, scientists thought about its future path as well. The same math and computer tools used to track its past can also predict where it will go. After swinging around the Sun, it kept speeding up. In a short time, as seen in space terms, it would cross into the great darkness beyond Pluto, beyond the farthest objects the Sun can easily reach. There, it would return to drifting between the stars, maybe joining other icy bodies on forever journeys through the galaxy. Learning about how 3I/ATLAS moved helped scientists answer some questions about safety as well. When new objects are found, it is important to learn fast if they could come anywhere near the Earth or the other planets. With 3I/ATLAS, careful tracking quickly proved that it would not come close to hitting anything big. Its sharp path placed it on a journey that was always at a safe distance. This allowed everyone watching the sky to focus on learning from it without worry. The speed and path of 3I/ATLAS also made it clear that watching such objects is not easy. Its visit was short. Anyone with a telescope had only a few weeks or months to collect every detail before 3I/ATLAS would be too far away to study. This motivated many astronomers to work together and to share information very quickly. Many countries joined in, making it a true team effort across the world. Another important part of tracking the object's path is looking at the tiniest changes in direction. These small changes tell scientists how the Sun's heat and light affect the movement of icy bodies. When the Sun heats the ice, it can push the object in tiny ways. Over long distances in space, even the smallest push can make a big difference in where an object will go. With 3I/ATLAS, scientists used very sensitive measurements to see if there was any change at all. They found that the object's journey was mostly smooth, with only small changes, which matched with what would be expected from normal gas leaving the surface. While moving close to the Sun, 3I/ATLAS gave another chance for learning. Sometimes comets break up or change quickly when they pass too close. But this visitor stayed together, showing that its mix of ice and rock was strong. This was a surprise to some scientists because other icy bodies have often fallen apart under similar heat. The path through space, the speed, and the way it held together all gave more pieces to the story of where and how it was made. The study of its path also helped answer questions about what kinds of forces push and pull small objects throughout the galaxy. In space, gravity from stars, planets, and even clouds of gas can slowly change a visitor's route. Over time, these gentle forces shape the long future of objects like 3I/ATLAS. As the team of scientists did more calculations, they could look for signs of such forces in the details of its journey. The team also shared what they learned with people who study space weather. When objects pass close to the Sun, they sometimes release dust and gas, which can then touch the wind and light from the Sun. These things are important for understanding not only visitors from other places, but also how the solar system's own small objects behave. This helps scientists solve bigger puzzles about how space works as a whole. Many scientists kept a careful record of every part of the movement of 3I/ATLAS. They drew special pictures called plots that showed every part of its path through the solar system. These plots are important for future research because they make it possible to remember the exact way the object moved, even after it has left and can no longer be seen. Other teams used the new measurements to check if there were smaller or very faint objects following the same path, but nothing unusual was found. The speed of 3I/ATLAS as it left the solar system answered more questions. It was still going fast enough that no gravity could pull it back. This meant that it had enough energy to keep traveling between the stars. If it meets no big object, no strong gravity, and no thick cloud, it will continue on this line forever, always moving through empty space, far beyond everything in the solar system. Because 3I/ATLAS came from so far away, its visit gave scientists a way to test what they know about the shape and motion of the solar system itself. By checking exactly when and where it passed by each planet, astronomers could examine how the planets, the Sun, and other objects pull on all visitors. This helps make even more exact models for the movement of comets, asteroids, and future visitors from other parts of space. The careful study of the orbit of 3I/ATLAS also brought new ideas to the teams watching the skies. They thought about how to improve the tools and methods for the next time a fast visitor arrives. Some developed new programs to spot faint dots in the sky moving extra fast. Others planned better ways to share discoveries so countries could work together faster. In this way, the path of 3I/ATLAS was not only a lesson about one object, but a lesson about how teams on Earth can learn and prepare for the next discovery. Alongside all these details, astronomers continued to wonder about the deeper history of 3I/ATLAS. In all the galaxy, many stars are born, grow, and sometimes move close to others. When this happens, the force called gravity can send small objects like 3I/ATLAS flying away from their home. Over millions and millions of years, these travelers fill the space between stars, moving in all directions, waiting for a chance event to bring them close to another star system, like ours. While people watched 3I/ATLAS, they also learned how special and rare such visits are. Even with all the telescopes in the world, only a few objects from other stars have entered the solar system since people started watching the sky carefully. Each new visitor is a reminder of how much space is still full of mystery and how small our solar system is next to the whole galaxy. When the object was about to leave, astronomers made sure they collected all possible information. They saved every detail about its orbit, its speed, each small change, and every way it reacted to the Sun. They knew that in only a short time 3I/ATLAS would be too far away to see again, and its visit would be over. All that would remain would be the careful records, the data, and the lessons learned. While the journey of 3I/ATLAS through the solar system was coming to an end, the scientists understood that they now had a complete picture of its path, speed, and the way it was changed by the Sun and by space itself. Every step of its journey gave more clues about how the universe works, and every scientist knew that their work helped build a story for everyone who is curious about the sky above. The passing of 3I/ATLAS was a reminder that the universe is always sending new things to be seen, understood, and shared with the world. With the path of 3I/ATLAS traced and its journey through the solar system followed from beginning to end, another set of questions began to rise. Many people, not only scientists, started asking if this unusual object, moving so fast and coming from so far, could bring any risk to Earth or the other planets. When something new and different is seen in space, there is always a mix of excitement and worry. News of 3I/ATLAS spread quickly, and some wondered if there was any reason to be afraid, or if this was just a moment for curiosity and learning. After the first reports, astronomers everywhere wanted to make sure that 3I/ATLAS was not going to pass close to our planet. They used exact measurements of its speed, position, and orbit. Mathematical models and computer programs helped check thousands of future paths, testing not only its closest approach to Earth, but also how it would move near other planets and moons. These calculations were shared in real time, allowing any possibility of danger to be clearly seen. It turned out that the answer was clear and simple. 3I/ATLAS would never come near the orbit of Earth. Its hyperbolic path, shaped by its incredible speed and unique entry into the solar system, showed that it would always stay at a safe distance. The closest it would get was still farther away than many other comets and asteroids that pass by on a regular basis. The object was going to speed by the Sun and continue into space, leaving both Earth and all the planets untouched. This news was important for the public and especially for people who look at the sky and sometimes become fearful when they hear that something new is traveling close to the solar system. Many online news sites, television shows, and social media accounts explained the situation. Scientists made sure everyone understood there was no danger. People were encouraged to look at the event as a way to learn and explore, not as a threat to life or the planet. Still, some people asked about other possible dangers. For example, they wondered if 3I/ATLAS could leave behind dust or anything else that might affect Earth later. Astronomers answered these questions with care. The size of 3I/ATLAS, its small dust cloud, and its distant path meant that it would not create any trails of dust strong enough to bring meteor showers or other events to Earth. The material escaping from the icy body would drift away in space, too thin and too far to have any effect on the weather or the sky. Safety teams at space agencies also looked for other possible risks. They checked whether 3I/ATLAS could come near any of the satellites or probes placed around the solar system. After careful tracking, they found no crossings or close passes with any important spacecraft. Objects like 3I/ATLAS are watched with extra attention because satellites are valuable tools for science and communication. Knowing there was no risk made it easier for everyone to watch the object with calm and wonder. Not only was Earth safe, but so were all the other planets. The orbit of 3I/ATLAS went around the Sun in such a way that it missed all of them by a very large distance. Even at its closest, it remained many millions of kilometers away from the nearest planet. It was only a visitor, rushing through without causing any change or harm. As the days passed, this understanding grew clearer. Scientists had time to focus on learning from the object instead of worrying. They studied the reports coming from observatories, checked new photos, and compared them with records from past visits by comets or asteroids. Communication between countries became very open. News was exchanged quickly to keep everyone informed. School teachers and parents talked about 3I/ATLAS with children, explaining that its journey was a chance to see something unique, not something dangerous. People from all over the world started watching the sky, hoping to catch a glimpse or read the next bit of news about this traveler from another star. Artists painted pictures, writers told stories, and photographers tried to capture its brief glow as it passed. Questions continued, but now they were full of wonder. Some people wanted to know how quickly the scientists had figured out its path. The answer was that discovery teams now have very strong tools. They learn the direction and speed of a new object very soon after it is noticed. In the first hours and days after 3I/ATLAS was found, teams worked through the night comparing measurements and running checks. They sent corrections to each other and built the path step by step. Only after repeating the checks many times did they speak to the public, knowing their results were very certain. The confidence came from years of practice and from clear plans made by space agencies. Scientists train for events like this because sometimes new objects do have orbits that could make them dangerous. Early discovery is the key to safety. Astronomers all over the world form a network. When one person sees a new moving point of light in the sky, they call other astronomers right away. Together they take more pictures, measure the path, and start building a list of its positions. The faster they do this, the sooner they know if the object is a simple visitor or something that needs extra attention. With 3I/ATLAS, all the checks were made even faster than usual because it was moving so quickly. There are now computer programs that let people add new observations right away. These programs take each new dot, each new time, and make a better guess at the full orbit. Even small changes help improve the result. After a few days, the path is more clear and more safe. Teams do not stop watching until the object is passed, just in case anything strange happens. Because of these strong habits, not only was Earth safe, but scientists could also use the moment to teach more people about the way science works. Reporters visited observatories. Schools ran activities about the solar system, space travel, and comets. Small clubs and big science centers both joined the excitement, letting people see pictures of 3I/ATLAS with their own eyes or read the latest updates online. The event also showed how much people trust science to protect and explain. Parents and teachers shared answers easily because information was clear. Astronomers joined in public talks, answered questions on radio shows, and helped people understand that 3I/ATLAS was not a risk, but a learning moment. The calm way teams worked together spread to everyone listening, making the event a moment of peace and discovery. The story of 3I/ATLAS also became a lesson in why scientists always check, even when things seem safe. Every day, telescopes search space for anything new or out of place. Special software looks for points of light that move strangely or shine only for a short time. When something is found, teams check it from many sides using math, old records, and careful planning. This is how they saw that 3I/ATLAS was a rare traveler and not a danger. Some people said that interstellar objects are one of the safest kinds of visitors simply because their orbits are wide and never close to Earth. While that is true most of the time, astronomers will never stop checking every new discovery. Space is very large, and sometimes objects move in ways nobody expects. Staying watchful and ready is the best way to be sure. The arrival of 3I at Atlas, then, was a perfect test of the world's early warning systems. It was only the third time scientists had seen something come from outside the solar system. But in all those times, the teams practiced sharing news, checking math, and working together. This made everyone more ready for any possible future dangers, even though 3I/ATLAS itself was always safe. The calm and careful work did more than solve worries about safety. It also brought people together. Countries that are very far apart shared their sky data. Scientists explained things in different languages so that everyone could understand. Even people who had never looked through a telescope before heard about 3I/ATLAS and learned to respect the care and practice that keeps the planet safe. During the days and nights as 3I/ATLAS passed by, a few people on the internet and in some stories still tried to say that every unknown thing in space could be a risk, but the quick and careful answers given by astronomers helped a lot. People could follow the real news, and their fears faded. Bit by bit, 3I/ATLAS changed from being something to worry about into something to teach and to wonder about. People everywhere began to talk less about danger and more about the science behind the discovery. New questions came up, such as how far 3I/ATLAS had traveled to reach us, what it was made of, and if other similar objects might come our way. As scientists answered these questions, many people learned a lot about comets, space rocks, orbits, and the solar system. There was a sense of being part of a discovery, even for those who would never look through a telescope themselves. This story also shows why scientists and science agencies need to work together, quickly and calmly, whenever something unusual is discovered. It does not matter how rare an object is or how small the risk. The habit of checking and sharing information everywhere makes everyone safer and smarter. 3I/ATLAS became proof that people can face the unknown not with fear but with knowledge and teamwork. Many schools and planetariums decided to use the story of 3I/ATLAS as a lesson. They showed students the exact path of the object, let them see images, and explained how orbits are calculated using math and telescopes. Teachers explained that even a discovery that brings no danger is still important because it helps people practice and get ready for new things that might come in the future. Observers and stargazers grew more interested as well. Some used home telescopes or even binoculars, sharing blurry but real photos on websites and with science clubs. A few science teams opened their observatories for public nights, letting families and small children see pictures or join in talks. The sense of sharing grew stronger, reminding everyone that the sky belongs to all people and that science is something everyone can join. By the time 3I/ATLAS continued its journey away from the sun, the event was remembered as more than a moment of worry. It was remembered as a time when people learned about orbits, teamwork, the reasons for safety checks, and the excitement of discovery. For the scientists, it was also a reminder to keep their tools sharp and their plans ready, because the universe is always full of surprises. The world had seen that when a rare visitor arrives, the best answer is careful checking, fast teamwork, and open news. In this way, newcomers from the far galaxy can become a cause for curiosity, happiness, and learning for everyone who shares the sky. When people felt safe and the first fears faded away, the focus changed again. Scientists, students, and anyone watching the sky now wanted to understand how experts studied 3I/ATLAS so closely, even though it was only here for a short time and always moving. Many wondered, how do astronomers keep track of something so small and fast, so far away? The answer starts with the tools and teamwork that make it possible to follow a traveler from far beyond the solar system. From the first moment 3I/ATLAS was seen, scientists decided to use every possible instrument to keep it in view as long as they could. There are many types of telescopes on Earth and in space. Each telescope has a special task. Some are very big and strong, able to see faint and distant light. Others can quickly change direction to follow a moving target. Some can look in colors of light that humans cannot see, like infrared or ultraviolet. Others are placed in mountains where the air is thin, or in deserts, or even beyond Earth, floating high above in orbit. The most useful tools are the ones that can work together, making the best use of every moment. The tracking of 3I/ATLAS began with normal telescopes. People on the first Discovery team looked at it night after night, writing careful reports. They wrote the exact time and position in the sky and shared this news online with other teams in different countries. Every group who could see it began to join in. Hundreds of photos were taken from places far apart. The world became like a network of eyes, each helping to follow the tiny visitor's path. Soon, larger research telescopes aimed at the object. These include some of the world's biggest observatories, working in places where the stars are sharp and bright. These big telescopes can see more detail. They can measure exactly how bright 3I/ATLAS is on each night and how it changes. By using special cameras and sensors, they record the way the object moves, the color of light it reflects, and the way that color changes over time. When people around the world use these big machines together, they make a complete picture of an object from many different places and times. Not only ground telescopes are important. Some of the most powerful tools for watching space are telescopes that float above our atmosphere, in space itself. These space telescopes are not blocked by clouds or weather, and they can see colors that are hidden from eyes on Earth. Space telescopes sent back images and measurements. They could study faint colors, the shape of any dust around 3I/ATLAS, and see things that are impossible to see from the ground. Special cameras called spectrographs were used as well. A spectrograph is a tool that takes incoming light and stretches it out into its many colors. Like a rainbow split up, every bit of the color band can show a different part of what the object is made from. This helps scientists find out what 3I/ATLAS has inside it, what gases are coming off, what kinds of ice are present, and even if the object carries simple organic chemicals or rare minerals. Each night, teams checked the spectrograph pictures, searching for small changes as the object moved and as the sun warmed it. Tracking an interstellar visitor like 3I/ATLAS also means using computers and software in new ways. Every photo, every measurement, and every time the object's position is written down becomes part of a huge data table. Advanced computer programs take this data, calculate the orbit, and show the expected path hour by hour. When these computers get new information, they update the object's route and predict where the object will be on the next night, week, or month. By working in teams, scientists avoided mistakes. If an error was found in one person's measurements, another team could compare their data, check for differences, and find the right answer. Astronomers from different places posted updates in public networks designed for sharing space news. Each night, many people around the world watched for updates, photos, and maps showing where 3I/ATLAS was on its journey. Not only professionals, students, and amateur astronomers also joined in. Many science clubs in cities and schools used small telescopes or even binoculars. When they pointed them at the right spot in the sky, sometimes they could see a faint dot or take a photo to add to the huge global record. Even families in their own yards took part for fun. Some people with home telescopes found creative ways to capture a short video as the object moved, a tiny dot among the fixed stars. This teamwork worked because the object was not going to stay long. 3I/ATLAS moved quickly. Every day it was in a new part of the sky, at a new angle, or hidden behind the sun from certain places. Some nights, only people in the southern half of the Earth could see it. Other nights, it appeared best from the north. By sharing information, teams made sure no one missed a chance to observe. Watches were set by atomic clocks to record the right time for each photo or reading. The brightness of 3I/ATLAS changed as it moved. At first, it was very faint. The biggest telescopes could see it, but small ones could not. As it came closer to the sun and a little closer to Earth, more light reflected from its surface. It became possible for smaller telescopes to catch it, at least in photographs taken with long exposure. When it moved past the sun and began to head away, the brightness faded again, and only the strongest telescopes could keep following it. Sometimes the brightness changes happened slowly, and sometimes they happened quickly as bursts of gas and dust floated off into space. Each change was written about and compared with past comets. The teams watched the shape of any tail, the color of the dust, and the patterns in the light. These changes were important. They helped show what kind of ice was melting, what rock was hiding underneath, and how 3I/ATLAS was shaped. Cameras studied the shape and size of the fuzzy coma, the cloud of gas and dust that forms around a comet or icy body when the sun warms its frozen parts. On certain nights, glows and halos were seen around the main dot of light. Astronomers used filters to look for gases like water vapor, carbon monoxide, or carbon dioxide. Each gas leaves a different fingerprint in the colors of light, and every fingerprint tells a part of the story. Measuring and tracking 3I/ATLAS also included following its motion very exactly, almost minute by minute, using computers to mark small changes in speed and direction. The motion was written down as numbers and plotted on maps. These plots became the main record of the whole event. Future astronomers can look back and read the charts to see exactly what 3I/ATLAS did while passing by. Such careful watching also made it possible to study if the object was spinning, as 3I/ATLAS reflected light. Some parts appeared brighter and others dimmer. If the object was spinning, these light changes repeated in a pattern. By studying this, teams learned how fast the object turned, if it was shaped like a ball or something longer, and if any of its surface was rough or smooth. One of the key lessons from following 3I/ATLAS was the value of sharing information quickly and working as a group. No single scientist or country could have followed the whole journey alone. By putting every picture, measurement, and note together, the world built a story that no one person could ever make by themselves. Science became a shared project, open to everyone. Over time, astronomers developed better ways to cooperate. Programs for automatic alerts, public data archives, and global news bulletins helped even small science clubs learn what to look for. If a telescope in the north saw a bright change, people in the south knew to point their own telescopes at that spot for a second look. Every discovery was tested and confirmed by more than one group. Telescopes in space added another layer. Instruments using infrared light could see dust and gas that were cold and faint. Cameras using ultraviolet could measure gases escaping that cannot be traced from Earth. These discoveries let teams learn the true size and shape of the tail and coma. Large amounts of data arrived every hour, and scientists ran special computer software to sort through the information. Some scientists also used radar, bouncing invisible waves off 3I/ATLAS to measure distance, size, and the speed it was moving. Radar is usually used for closer objects, but it can sometimes pick up features of big, fast-moving space objects. The radar teams added their results to the shared records. As the weeks passed, small changes in the path of 3I/ATLAS were noticed. Occasionally, the warmth of the sun made jets of gas shoot out of the object, making it move a little bit differently. These changes, called non-gravitational effects, were tracked closely. Each one showed the power of natural forces in space and helped improve the math that predicts comet paths. Learning from 3I/ATLAS tested not only the tools of astronomy, but also the organization and creativity of teams everywhere. As the object moved away, some telescopes switched to other science tasks, but the data was kept safe. Charts, graphs, and photos were stored in public databases so that anyone interested could learn from them later. Even after the object was out of sight, the story of its visit could be told and retold, helping others practice for when the next visitor comes. Small mistakes or gaps in tracking were also lessons. On some nights, weather or other problems stopped people from getting good pictures. This made scientists talk about even better ways to work together, with more backups and more shared information. The experience led to new ideas for faster software, better sharing, and even new telescope designs to catch the faintest, fastest moving things in the sky. Every detail learned about 3I/ATLAS became part of our knowledge about the solar system and the galaxy beyond. By working together to study and follow this one visitor, people learned more about how our own planet and our place in space connect to the bigger universe. The joy of discovery, the challenge of hard work, and the power of science all came together. The excitement of tracking 3I/ATLAS encouraged more people to join the search for space objects. Students began thinking about careers in science. Science clubs and museums welcomed more visitors. New software was built so that in the future, even more people can help watch and record new discoveries. After all the hard work, as the comet faded and left the solar system, the teams could look back on a job well done. Every photo, every chart, and every new friendship among watchers of the sky became a part of the story of 3I/ATLAS. The lessons learned would not be forgotten. They would be saved, used, and improved for the next bright spot of surprise in the sky. The tracking and study of 3I/ATLAS showed the world what can be done with patience, good tools, and teamwork. The object's quick journey gave a lesson to all, from expert astronomers to young students, and even to families simply watching the night. It gave the world a glimpse of the bigger universe and reminded everyone that there is much more out beyond our sun, ready to be found, learned, and shared. As the information about 3I/ATLAS was shared and the details of its movement and materials became clear, many people became even more curious about its connection to the ideas of life far away and messages sent into space. They wondered if there could be any link between the arrival of a traveler from another part of the galaxy and one of the most famous things humans have ever sent into the universe, a message from Earth itself. Almost 50 years before 3I/ATLAS was found, scientists in Puerto Rico used a huge radio telescope at a place called Arecibo to send a special message into space. This happened in the year 1974. The scientists sent this radio signal as a greeting to anyone or anything that might be listening among the stars. The message was made up of a pattern of numbers and shapes that showed basic facts about humans, the solar system, and our planet. Scientists hoped that in the far future, another civilization might read it and know that people on Earth wanted to say hello. This radio message from the Arecibo Observatory became famous as the Arecibo message. When news of 3I/ATLAS reached the world in the year 2025, the coincidence was not lost on many people. It had been nearly half a century since the Arecibo message was sent. Some people, both scientists and those who love to read about space, started to ask new questions. Could there be some link between the two events, the message from Earth and the arrival of an object from another star? For many, it was a fun puzzle. They noticed that 3I/ATLAS did not move or look exactly like the usual comets or asteroids. Its fast speed, the way its path was shaped, and its distant origin stood out. There was something mysterious about an object coming from deep space not long after humans tried to reach out to the universe. News stories and social media places quickly picked up the idea. At first, some people just played with the thought. Others wondered more seriously if 3I/ATLAS might be a kind of answer sent by intelligent beings somewhere beyond our solar system. This idea spread for many reasons. People have always dreamed of meeting life from another place. Stories about space visitors and signals from the stars are popular in books, movies, and television. The arrival of something new, so close to the anniversary of the famous space message, gave everyone feelings of hope, excitement, and a wish to believe. Some reporters asked astronomers if the arrival time matched up well with how long a message or an object would need to cross the distances between stars. They wanted to know if it was possible an answer could come back in less than 50 years. Scientists explained carefully that even at the speed of light, the Arecibo message would travel only about 25 light-years in that time. A light-year is the distance that light covers in a full year. Almost all stars, planets, and objects are much farther away than this, often by thousands or millions of light-years. The expert said that because 3I/ATLAS came from so far, it was not possible for it to be an answer to the message humans sent. Even if another civilization had received the Arecibo message at once, they would need a lot of time to learn about it and send something back. In space, distances are so huge that messages and objects both take very long periods to travel. Still, the fun idea was not easily forgotten. People made drawings and wrote stories. Some asked if anyone had checked to see if 3I/ATLAS carried any signs of being a message, a pattern, a special signal, anything that might say it was not just a rock and ice body. Astronomers liked the excitement but wanted to be careful. They said that before claiming a link, they needed to look at every possible fact with calm minds. As soon as the idea started to spread, scientists returned to their careful study of all the measurements made on 31/ATLAS. They checked the light coming from it, looking for any pattern or flash that did not fit normal science. They listened with radio antennas to see if any signal, pulse, or repeating sound could be found. They searched the shape and path for designs that could only happen if someone or something had made the object rather than nature itself. In all of these checks, the team saw the same thing. 3I/ATLAS moved like a natural object thrown out from a distant star system. Its color, spin, light changes, and even the gases that floated away when the sun warmed it matched what was expected of an icy body from space. No patterns or odd signals were found. There was no flashing light or regular sound that would show technology. In every way that people could measure, 3I/ATLAS was a piece of nature, not a message or machine. This was not a disappointment to the scientists. They explained that finding an interstellar rock made by forces at work around another star is already very rare and special. Every feature helps people learn what kinds of places and events exist in the larger Milky Way galaxy. The excitement of a possible link with the Arecibo message made people ask questions and learn more about how science works. But some people wished for more and continued to talk about ideas of alien contact. Public talks, school lessons, and magazines covered the story. Experts invited everyone to learn the facts about the distances in space and the nature of comets and asteroids. They reminded people that finding proof of life beyond Earth will take patience and careful study. The idea lives on, but always with the need for strong evidence. The story of the Arecibo message and 3I/ATLAS became a way to teach more about radio waves and how humans have tried to make contact with the universe. People learned that since the year 1974, many other messages and signals have also been sent into space in hopes of finding others or simply showing that we are here. These include records, pictures, and even greetings placed on spacecraft designed to leave the solar system forever. Teachers used the story to explain why the universe is so silent and empty, even though it is full of stars. The distances make messages very slow. Light moves at the fastest speed known, yet even it takes years to cross the space between stars. This is why news about possible signals or mysterious visitors always comes with great excitement and much questioning. The fun idea about 3I/ATLAS being a sign of alien life made people want to learn how to tell if something is natural or maybe made by technology. Astronomers said that natural objects usually spin or move in certain ways, have surfaces made of lots of simple elements, and reflect light in uneven patterns. A machine or tool made by life would probably move in straight and steady lines, send repeating signals, or have surfaces too smooth and shiny for nature alone. For 3I/ATLAS, every check came back as normal for a big piece of ice and rock from space. The object's path across the sky was set by gravity, its gases and tail formed by warming from the sun, not by any engine or fuel. Its surface was rough, changed by millions of years of dust and radiation, not polished or covered by any known material from technology. Stories about contact with other life will always be important to people, and every mystery in the sky makes hopes rise. Scientists said it is good to ask and wonder, but always to remember what evidence looks like. They promised to watch every new object as carefully as possible and to share what they learn, hoping that one day, maybe, a real message or real signs of life could be found. The event also brought up new questions about communication across the galaxy. Some people asked how scientists pick what to send into space, or what would happen if any answer ever came back. Experts shared that messages are usually made to show simple facts, like pictures of people, numbers, or maps of Earth and the solar system. The hope is that if any intelligent life is out there, it can learn something about the senders and maybe send a message of its own. Until now, no answer has been found, and the wait continues. On television and the internet, the story of 3I/ATLAS and the Arecibo message showed how closely people follow space news when it makes them dream. Even though the objects in space are silent and cold, they light up the imaginations of everyone who hears about them. Some young people decided to study science or to learn about radio waves, telescopes, and the galaxy just because they read about this strange visitor and the hopes around it. Museums and science centers made special programs with computer games and activities. Everyone could try to make their own message to the stars or to look for answers in the patterns of real comets observed. The scientists who watched 3I/ATLAS looked again and again for any sign outside nature just to be sure. They agreed that their greatest job was to search for the truth, to check every new question, and not to rush to answers. They remembered that in the history of space, most mysteries have turned out to be nature's work. As the story went on, more people came to understand that science works best when everyone can see the facts. The wonder of space, the search for new messages, and the hope to find friends in the stars will always continue. For now, the best tools are careful measurement, open communication, and patience across many years and journeys. Many media told the story of how the Arecibo message is still going, moving farther and farther every year. It may never be found by another civilization, but it reminds us that sending news of ourselves is one way to explore the universe. When a strange, fast object like 3I/ATLAS appears, we are reminded how wide space is and how many secrets still fly between the stars. Sharing stories about the Arecibo message and 3I/ATLAS became a moment for everyone to celebrate curiosity, hope, and the joy of looking up at the night sky. When people everywhere ask about what comes next, they show that searching the heavens is something that belongs to everyone, all over the world. While people were asking questions and imagining new possibilities about 3I/ATLAS, scientists kept working to find out if there was any real clue that this object was more than just ice and rock from space. Every new discovery and idea was tested over and over because science depends on careful checks and clear evidence. Some wanted to believe that 3I/ATLAS was a message, a machine, or even a visitor from another civilization. For that to be true, there would need to be facts that could not be explained by natural causes. So astronomers focused on detailed investigations, using all the best tools and teamwork they had. All of the information collected about 3I/ATLAS was sent to teams all around the world. They reviewed photos, brightness levels, and records of the object's movements. One of the first things they looked for was any hint of design or technology in how it traveled. Natural space objects follow paths set by gravity and their own motion. Sometimes natural events like a burst of gas or dust make small changes in direction, but machines might show repeating, smooth, or sudden motion that does not fit what is normal for a rock or a comet. Every study showed the movement of 3I/ATLAS was fully explained by the natural laws of gravity and sunlight. Its path was open and fast, just as expected for an object from outside our solar system. Its spins, slow turns, and changes in brightness matched what scientists see with other icy bodies that come from the outer parts of space. There were no sharp turns or patterns in its movement that could not be tracked to sun heat or dust jets climbing off its surface. The next test was to listen carefully for signs in radio waves. If a machine or intelligent being wanted to be found, it could use special signals, repeating beeps, unnatural static, or messages that do not match patterns from space. So, many large radio telescopes from different countries pointed at 3I/ATLAS as it passed by. They recorded sounds and radio waves for days and nights. They compared what was heard with what stars, comets, and natural gases give off. No repeating pattern, beeps, or odd sounds were found. Scientists concluded there was nothing different in the radio waves that could be a signal or message. Examining the object in visible light, telescopes checked for flashes, shining points, or any line or mark on its surface. Photographs from space and the ground saw nothing strange. No shiny plates, no lines, no reflections from metal or other artificial objects. Everything seen matched dirty ice and rock, just like nature makes in many dusty clouds around stars. To go further, scientists turned to spectrographs. These machines, by breaking light into many colors, can show what the object is made from. The idea was simple. A machine or a body that is not natural could show minerals, metals, or chemicals made by factories or technology. Instead, what was found again and again was familiar: ice, simple kinds of rock, dust, faint organic matter, carbon, and a little ammonia. These are all normal parts of a comet. No rare or unusual material appeared. The colors and fingerprints from 3I/ATLAS matched what scientists already know from other comets and asteroids. Some groups searched for perfect shapes, straight lines, flat surfaces, sharp corners that nature rarely makes in a rock or ice. High-powered telescope images were checked for regular forms, repeating designs, or pieces that stayed locked in place as the object spun. All pictures showed a rough, uneven body shaped by long years in deep space. There was no symmetry, no signs of cutting or building. The surface looked weathered, as if struck by small space dust for millions or billions of years. Another check was on the tail and coma, the faint cloud that forms when the sun warms an icy piece of space rock. If the tail came out in bursts or as a thin, even flow, that said something about what was inside. For 3I/ATLAS, the gas and dust left the surface in a way that matched heat and pressure from the sun. The tails were thin, mostly pointing away from the sun, and changed only when the shape or spin brought a fresh patch of ice into sunlight. No straight lines, no controlled bursts, no heat or glow from engines or power was ever seen. Teams also watched for color flashes or light pulses. Sometimes machines can blink or send out flashes. Many sensitive cameras collected hours of light from 3I/ATLAS, but found nothing that acted like a signal. Every flash was checked, and all were shown to be sunlight, space dust, or ordinary rocks. As scientists compared all their data, they saw that every clue pointed back to natural causes. 3I/ATLAS looked, behaved, and changed just like the comets and icy bodies seen hundreds of times before, except for one thing. It came from outside our solar system. The speed, path, and every reaction to light or heat fit with what is known about natural objects that get kicked out of other star systems. Many people kept hoping for an exception. They asked if a machine from another world could be made to look like a natural rock, or if some message could be hidden deeper than the tools could find. Scientists said that all the best technology on Earth had been used for the search. If there had been any sign of design, message, or machine, it would have appeared in the careful checks. Even so, they promised to keep every piece of information just in case better tools in the future could find something new. A few more ideas were tested. For example, some looked at the math of how 3I/ATLAS spun. If an object is made on purpose, it could spin in a way that is too smooth or at a speed that matches a clock. But 3I/ATLAS spun slowly and unevenly, as if shaped randomly and then left to turn under the pulling force of sunlight and gas escaping from its own body. Others asked if a trail might be left behind, either small objects, broken parts, or strange materials. Space telescopes checked the skies after 3I/ATLAS passed, but saw no unusual pieces, no chain or string of small bodies, and no changes in the area the object had crossed. Just the usual dust, so thin that Earth and the planets would never even notice. There was also the question of orbit and destination. If someone was steering 3I/ATLAS, it might aim at Earth, the Sun, or other places. But all math showed that its path matched the curves made by gravity and its own speed for millions of years. There was no sign the orbit had been changed outside natural causes. All these facts, gathered by scientists from every continent, pointed to a single answer. 3I/ATLAS was born from natural forces. Many billions of years ago, somewhere around a distant star, clouds of gas and dust became ice and rock. Maybe a planet formed close by, or a bigger piece broke apart. The rock or ice of 3I/ATLAS was thrown free, heading out into deep space. For millions or billions of years, it drifted in the cold and dark. Only by chance did its path cross our solar system, making it possible for humans to see and study it. The reason that so many checks and questions were asked was simple. Learning about nature does not happen fast. It needs teamwork and patience. Each time something unusual is spotted in the sky, excitement grows. But the real work is careful and takes time. That is how science finds what is true and what is only a hope. Some experts talked about how often unexplained things in space turn out to be normal after more checking. Planets, stars, comets, and other objects can move in ways that surprise people at first. Sometimes, just because an object is rare, its arrival sets off ideas of messages or life. The real answer requires proof, not just wishes. This is why science depends so much on evidence. Over and over, the story of 3I/ATLAS became a lesson in how people search for meaning, but trust the work of science to say what is certain. By sharing information, checking facts, and joining together from all over the world, the truth about the strange visitor was confirmed beyond any real doubt. The search for non-natural clues was also a reason for more people to learn about how science works. Books, news, and school lessons told the story of how teams test, question, and make sure before saying something is real. Instead of guessing or getting excited without reason, teams let evidence lead every step. This way of working, watching carefully, measuring all possibilities, and thinking about every detail, makes it possible for humans to answer some of the biggest questions about the universe. The visit of 3I/ATLAS showed how much can be learned with the right tools and a spirit of teamwork. The story brought hope and curiosity to young people. It inspired new dreams and ideas about what might still be found among the stars. In the end, all the results from telescopes, cameras, computers, and radio antennas became part of the story of this icy object. Experts said that finding and confirming an interstellar object is already an amazing result. Each discovery helps scientists make better tools and better questions for future visitors from space. And if something new and strange ever does appear in the sky, the world now knows how to look and how to check for signs of anything more than what is expected. People went back to watching the skies, waiting and hoping for the next big discovery, whatever it may be. The feeling left by 3I/ATLAS was a mix of wonder, not only because of dreams of other lives, but because the universe is much bigger and more amazing than anyone can fully imagine. The journey of 3I/ATLAS proved that the universe is full of things to explore, all waiting for new eyes to see and understand. Every night, as the sky grew dark, people around the world looked up and wondered about what more could be learned from visitors like 3I/ATLAS. The study of this interstellar object brought many answers, yet even more questions. Scientists were especially excited because each object from outside the solar system brings a chance to study things that cannot be reached by rockets or space probes. These objects are like small messengers from faraway places, carrying secrets about how stars and planets form in other parts of the galaxy. For many years, astronomers had only guessed about the things that might exist around other stars. They used telescopes to see planets, dust, and light across the empty space, but most objects were too far away to touch or study closely. The arrival of a third interstellar object changed this. 3I/ATLAS was only the third time in all of known history that something from outside our solar system passed close enough to be seen, measured, and understood in detail. Scientists wanted to learn as much as possible from this rare visitor, not just for the sake of one discovery, but for what it could show about the universe itself. Every detail could be important. The size, shape, color, and brightness of 3I/ATLAS all kept a record of what happened to it during its journey. The makeup of its ice, rock, and dust could give clues about the kinds of places it came from and the forces that shaped it over millions of years. One of the most powerful ways to study a visitor like 3I/ATLAS is to look at the light it reflects from the sun. When sunlight hits the object, some of the light bounces back to Earth. That light can be broken apart into its colors by scientific tools. Each color band or wavelength can show the fingerprint of a different material. Together, they reveal what kinds of molecules and elements make up the visitor. If a new kind of gas or mineral is found, it opens a new window into how different parts of the galaxy create their planets and objects. The search for new materials is one reason interstellar objects are so important. In our solar system, comets, asteroids, and planets have certain common elements: carbon, oxygen, hydrogen, nitrogen, and a few others. If astronomers see something that does not match, it could mean the visitor started around a star with a totally different history. Maybe a larger planet or a hotter sun shaped how its icy parts and rocky shell were made. Each fingerprint in the light is valuable information. Along with searching for new minerals and ices, scientists studied how 3I/ATLAS changed as it got closer to the sun. In space, when an icy body warms up, it starts to let out gas and dust. The color, thickness, and shape of this cloud, called a coma, tells a story about what is inside. If a visitor from another star system has a coma that is different from anything seen before, it could mean there are unique chemicals, or that its home star changed it in a way never found in our solar system. As they carefully watched the coma and any tale behind the object, scientists learned even more. The way the sun's heat and light pushed the small bits of gas and dust showed how strongly these forces work far from Earth. Some little grains may have carried simple organic molecules, materials that are common throughout space, sometimes even in places where life forms. Though these are not signs of life, they tell what is possible in the many worlds that fill the galaxy. Chemical studies did not only help people learn about distant places, they also helped test the ideas about how the first stars and planets formed billions of years ago. By comparing the dust in 3I/ATLAS to dust in our own comets and asteroids, scientists could ask if the building blocks looked the same everywhere, or if every part of the universe is different. Each visit by an interstellar object gives a new piece to this puzzle. The data from 3I/ATLAS also tested and stretched the technology used by people who watch the sky. Because the object moved so quickly and would not stay for long, teams needed to point their telescopes very fast and work together to record every possible fact. This made them improve their tools, their computers, and the way they shared what they learned. Everyone had to work faster and smarter, learning by doing as much as by reading books. This teamwork brought many new friendships and plans for the future. Astronomers from Asia, the Americas, Africa, Europe, and all across Australia shared pictures, information, and ideas. Some had different ways of measuring or used other parts of the light spectrum, but together they checked each other's results. By working together, mistakes could be found and corrected early, and the picture of what happened became clearer for all. The discoveries that came from 3I/ATLAS also helped many young scientists and students. When news about an interstellar visitor spreads, it often inspires people who had never looked through a telescope before to join in. Science clubs held events where people could use their own eyes or see photos in real time from big research centers. Teachers built lessons around the discovery, showing students how a real object from another star could be studied on Earth. The open sharing of data from 3IATLAS made it possible for anyone to follow the journey. Many websites offered live charts, updated photos, and models that let people see the path of the object hour by hour. Some even let users hear sound generated from the light signals, turning science data into music or pictures in new ways. This kind of open science helped show that learning about space can belong to everyone. Another important reason to study 3I/ATLAS closely was to confirm whether other solar systems make objects the same way as our own. If scientists could find that ices, rocks, and dust are built up from the same chemicals everywhere, it might mean that planets and other bodies like Earth could be common throughout the galaxy. If something very different was found, it would tell us about new and unknown kinds of worlds. Each detail found on an object like 3I/ATLAS teaches a lesson about the history of space. Its speed, path, and chemical fingerprints showed the power of gravity, heat, and time. The record of its journey through the solar system became a textbook for new students. By learning from its visit, people gained ideas about the birth of planets, the mixing of gas and dust around young stars, and even about the oldest days of the galaxy. Another result of the study was to improve the way scientists look for new objects. With every interstellar visitor, people improved the speed of their computers, the design of their telescopes, and the ways they told news to each other. This made science faster and more helpful for the next time a fast object is discovered. Early learning from 3IATLAS made it easier for the world to work together the next time a new object came close to the Sun. Studying 3IATLAS also gave practice in how to act quickly and carefully. Because the visitor was moving away so fast, every night mattered. Teams learned how to plan their time to watch it at just the right moments, and to hand off from one part of the world to another as the Earth turned. The experience showed that good teamwork can make a big difference in science, no matter where people live or what language they speak. Some of the most exciting measurements of 3I/ATLAS came from places that are hard to reach in everyday life, like mountaintop observatories or deep space telescopes. But people everywhere could watch the results and learn from them. Sharing became part of the process, helping to raise new questions for the next discovery. Every new visitor from between the stars brings the chance to see something never found before. 3I/ATLAS was studied more closely than almost any icy object in history, except for a few comets that have had satellites sent close by. The work done helped shape the way future discoveries will be studied. Teams are now better prepared for the next object that may come from far beyond our Sun. Learning from interstellar objects like 3I/ATLAS also brings hope to people who wonder about life in the universe. The more is known about the common parts of dust, ice, and rock, the greater the chance that somewhere, Earth-like places may also exist. Some of the chemicals found in such dust are known to be important for life, though none are proof by themselves. The dream of finding something living, or some sign of it, is made stronger with each new discovery. When the studies were finished, the research was written in many books and scientific papers. The knowledge was shared in museums, classrooms, and on television shows. The story of 3I/ATLAS entered into the history of space study, showing how the universe can surprise us and make everyone curious again. Young people were encouraged to look for more, to use science to explore and to ask their own questions. Knowing more about interstellar objects also helps people learn about keeping Earth safe. When fast-moving bodies from far away cross the solar system, it is important to check if they are a danger. Scientists have built better warning systems and alerts so that if any object ever comes close, people will be ready and not afraid. In the end, the real meaning of studying 3I/ATLAS came from everything that was learned and shared. The object showed that Earth is part of a big and changing universe. It reminded everyone that every new object seen in the sky is a chance to ask, what can we learn next? Science is not only about answering old questions, but about finding new ones for the future. For all those who watched or learned about 3I/ATLAS, the experience brought the world together. Scientists, students, families, and people of every age found reasons to look up and wonder. With every new visitor, the bond to the wider universe grows, and the journey of curiosity continues. As the excitement around 3I/ATLAS settled and scientists finished gathering their last bits of information, curiosity and hope remained everywhere. People wanted to know what this event really meant and how it would change the way space is studied in the future. Even after the icy visitor left the solar system, its story continued to live on in new ideas and dreams all over the world. One of the first things that people began to think about was the idea of future discoveries. Because of 3I/ATLAS, the hope grew that more interstellar objects would be found. Each time one of these rare visitors arrives, it brings a chance to learn about places that are impossible to visit any other way. These objects are like pieces of other worlds sent to Earth by the universe itself. The experience with 3I/ATLAS taught scientists how important it is to look up, pay attention, and be ready. Space telescopes, ground telescopes, cameras, and even computers all improved as people learned during the passing of 3I/ATLAS. Scientists learned to share information more quickly and to check for moving objects that travel fast and shine faintly. Before, only the biggest and strongest telescopes could spot an interstellar object. Now smaller teams and even those using school or backyard telescopes have more tools and more ways to be part of a discovery. People everywhere have new reasons to look up at the night, searching for the next surprise from the galaxy. The tools used to find and study 3I/ATLAS also taught scientists many lessons about teamwork and planning. When a new object appears, there is not much time before it moves too far away to observe. Scientists must work day and night, making sure that every part of the data is shared and every observation is made at the right moment. This close teamwork is not just for astronomy. It is a way to solve problems and learn together that can help in many areas of life. Another important lesson was about communication. During the days when 31/ATLAS was visible, news traveled faster than ever. Information about its position in the sky, the kind of material it was made from, and photos of its tail and coma all reached people in every country. Students followed charts, science clubs set up meetings, and families checked online for new videos and facts. The excitement showed that sharing information and making science open to everyone makes each discovery more meaningful. As scientists looked back over the journey of 3I/ATLAS, they also asked new questions about exploration. They began to wonder how much more could be learned by reaching farther, going faster, or building new machines for studying space. Some talked about sending small spacecraft to follow interstellar objects, capturing samples or taking close-up photos. Others wanted to build better sensors to spot faint dots just as they enter the solar system. Every part of this discussion was shaped by what was learned from 3I/ATLAS. Scientists also spoke about the need to search for worlds around other stars. Interstellar objects show that parts of faraway systems can reach Earth, But what about visiting other systems or finding planets that might even have signs of life? Some people dreamed of new kinds of telescopes, ones that could see the surfaces of planets light years away. Others wanted to develop space probes that could travel faster and return information from beyond the sun's reach. People everywhere, not just scientists, began to talk about the dreams of finding life in the universe. Each visitor, like 3I/ATLAS, suggests that material and rock can cross the huge distances between stars. If simple building blocks travel so far, then maybe life, or at least the parts needed for life, could move between systems too. Teachers shared these ideas with students, and whole classrooms filled with questions about how life might spread, what forms it might take, and what humans might do if a real discovery was made. The study of 3I/ATLAS also helped science in another way. By watching how an interstellar object moves, scientists tested the ways they watch for danger from space. Even though 3I/ATLAS was never a threat, all the steps taken, checking its path, measuring its speed, and studying its course, helped teams improve warning systems that protect Earth from possible impacts. The drills used for this visitor made people safer and faster at reacting to the unknown. Space agencies and researchers began new projects with renewed energy. They made plans to watch the sky with more detail, to see even smaller or faster things. Some set up computer systems to send instant alerts if something new moved across the sky. New programs were started to teach and train students in the skills needed for space discovery. All these plans would help people be ready for whatever comes next. At the same time, memories of 3I/ATLAS continued to inspire. It was a story that brought strangers together, from professional scientists to young children who had never before wondered about the stars. It encouraged people to ask questions, to search for answers, and to think about the place of humanity in a universe much bigger than anything seen before. Many people wrote stories, made art, and created projects because of what they learned. Museums set up special displays showing the path of 3I/ATLAS through the solar system. Science clubs made posters and built models. Children asked new questions at bedtime about what else was out there. The sense of wonder spread beyond classrooms and research centers into daily life. The experience also changed how scientists think about the future. With every new tool, idea, and group of people who want to learn, the chance of finding more interstellar objects grows. The methods for searching the sky, for checking the safety of the planet, and for sharing discoveries are all stronger than before. This means that even bigger and better surprises could be waiting. Astronomy never ends because the sky is never finished. Each night brings a new chance to find something no person has ever seen. Each new visit from an object like 3I/ATLAS is a message from the universe saying that there is more to know. And every answer brings a new question, helping people stay curious, creative, and patient as they wait for what comes next. Scientists also learned the value of including more voices in every discovery. They saw that when information is open and when anyone is welcome to watch the sky or help with a search, everyone becomes part of the adventure. This way, young people grow into scientists, and people who once just looked up for fun begin to learn and ask more. As years passed, teams continued to follow up on small pieces of data from 31/ATLAS. Even when the object itself was gone, the measurements and pictures collected were used to teach, to test new ideas, and to plan new missions. Old data was checked for new secrets as technology grew. Some scientists re-examined tiny changes in the photographs, hoping to find a detail that was missed. Others used what they had learned to practice for the next discovery. Time after time, the story of 3I/ATLAS was brought up as a reason to support science, to teach new generations, and to remember that the world can unite in wonder. Each country, large or small, could play a part in understanding the galaxy. Science centers held open nights. Observatories invited the public to see the sky. Artists made new works. All of these things showed that space belongs to everyone, and discovery comes from sharing. The path of 3I/ATLAS also changed the questions scientists ask about the solar system. They now wonder just how many interstellar visitors have come and gone, maybe before people even had telescopes to see them. Could some have broken apart, leaving fragments that now circle the sun or sleep in the darkness, waiting to be found? Every answer leads to more studies and the search for other ways to detect these hidden travelers. Everything studied from 3I/ATLAS became a step forward. The journey it made through space and the careful notes written by so many people created a resource. This resource can be used when teaching in schools, making new technology, and inspiring groups to look for the next light in the sky. The hope and excitement brought by 3I/ATLAS reminded everyone that even a small cold object from far away can have a big effect on the world. When people share, learn together, and look after each other, every discovery becomes something greater. Astronomy is not just a science for experts, it is a way for every person to join in the adventure. As the years go by, new generations will continue to look up, searching for another 3I/ATLAS. The tools and knowledge will be better, the teamwork will be stronger, and the surprises waiting in space will still be as wonderful as ever. Each discovery will add to what is known, and each person who joins the journey will help to tell the story of our search for the unknown. The story of 3I/ATLAS is now part of the history of science, a sign that curiosity and hope will always be at the heart of looking up at the stars. The study of one object can bring people together from all over the earth, crossing borders, languages, and generations. In the end, perhaps this is what matters most. Every time something new crosses the sky, it gives people a reason to gather, to wonder together, and to remember that the universe is vast and open and full of secrets yet to be found. Science, like the sky, never closes, and 3I/ATLAS will always be a sign that the search goes on.